you guys doing?
Doing
Good,
good.
thanks.
How about you?
It's good to see y'all out of a windy Denver, and
Yeah.
I appreciate you taking the time. What we have is Raechel Sherwood, who's CEO and co-founder of Loxley Systems, and Steve Sherwood, who's president and co-founder of Loxley Systems. So it looks like I got the two co-founders here, or else it would be a tri-founder, and that's not happening. So
That's not us.
let's have co-founders. And
Just co-founders.
so it's a Saturday morning
Yep.
because you have busy schedules, and I couldn't get you during the week because you're just too busy. And so I appreciate you taking out your Saturday morning with me with a little bit of coffee and a little bit of cereal and talking about extraction, or in this case, we're really talking about separation. And so to start everything off, I don't know if everyone knows about Loxley Systems, but I thought I would give Raechel a chance to explain what Loxley Systems over in the big picture, and then we can get down to some of the more esoteric details.
Nitty gritty. Yeah. Well, thanks for having us, John. We're very excited to be a part of this, even on a Saturday morning. It's a good way to start a Saturday. Loxley Systems, I'm sure a lot of people haven't heard about Loxley Systems. We're pretty new to the market, but not new in terms of product. So we actually founded way back in early 2017 with the mission of creating a solventless, safe, clean, and limitlessly scalable separation tech for cannabis and terpenes to try and move the industry away from solvent extraction and from tedious downstream processing. So when we started in 2017, we had many iterations of designs and ideas that we moved through. And after 4 years and a couple $1 million of research and development time and money, we now have a full fleet of systems. So we have 5 series ranging all the way from 10 pounds a batch to 50,000 pounds per day continuously, and anything you want in between. So now that we're finally with our full fleet of products, we're hitting the market for the first time.
Yeah, I think the ultimate goal of our system was to develop a process that would give you a distillate quality cannabinoid oil out in clean terpenes without any requirements for further upgrading. So it's essentially a one-step process to get both those products.
Well, it seems like a pretty simple thing to do. I don't know why it took you so long.
We were like, if this was easy, someone probably would have done it by now.
Right. And that would have covered a couple of the patents too. Would have saved you a little writing time and lawyer fees.
True.
Yeah.
True. Yes, the filing of the patents took a couple of years.
Getting through all this process and starting that far off, and my last person on the podcast was a University of Colorado Boulder graduate, and I can tell from LinkedIn that you're also a Boulder graduate, so it must be some sort of phenomenon. And all the technology.
So is Steve.
Yeah.
Oh, really?
Oh yeah.
Yeah.
We're both alums.
Yeah, that and Colorado School of Mines.
Oh, Colorado School of Mines.
Yeah.
Yeah. Oh, well, that's another whole ball of wax. I don't usually talk to those people. It's not my bailiwick. So if I look at that, where did you? What happened after you left Boulder, Raechel? I don't know what happened to you, Steve. I'll get to that in a bit. But Raechel, where'd you end up?
So I actually went to New York, East Coast, after I graduated. Lived in New York City for a few years and worked for a biotech startup out there, which was a great startup education. It was also bringing a new tech to the space. So it was a lot of fun. We worked on stem cell collection, stem cell generation, and application therapies, essentially. And I worked in the marketing and sales area there. And then one day Steve called me up and said I needed to turn on CNN and watch a documentary that was running about the very new at the time cannabis industry in Breckenridge, Colorado, which was really near and dear to our hearts. Our family cabin has been there for over 50 years. And so we just recognized all the spots in the documentary. We thought it was really fascinating. And he called me up after we watched it and said, there's just got to be a better way to do this.
Yeah, they had a section on extraction with CO2. And I didn't even know you could extract oils from the plant. I'm familiar with mineral extraction and solvent extraction to recover minerals and gold and things like that, but I've never worked with botanicals before. So I started looking into it and try to get more information on the CO2 extraction, supercritical, things like that. So I built my own little CO2 reactor from Swagelok parts and tubing and was able to generate some oil. And after that, I said, Raechel, we got to start thinking about maybe doing this a better way. Because I did a little bit of work with ethanol extraction, saw the problems with that, and said, there's got to be a simple way to recover these oils without going through a solvent. And the first thing we did was built a continuous rosin press, which turned out to be a miserable failure.
It did not work, but there are 10,000 ways to not make a extraction system, we've discovered. So.
But we came up with a separation technology that we thought would work, located a facility, a marijuana manufacturing facility in Boulder that allowed us to set up in their facility so we could actually test the system out. And the first products we made were just burnt and they really were not usable. And these people were really hard on us to make something that could be used in a vape pen directly from our system. It took about 9 to 10 months. We finally were able to do that on a bench scale. We made a beautiful product.
Smokable, dabbable, edible, right out of the system.
So the next thing to do was try to scale this up from a couple 100 grams an hour to 100 pounds a day. And we built a beta system, did the similar technology. It wasn't optimized for this, but we were able to get product out. It wasn't the best product, but we were able to get something out. From that point, we had a gentleman, a farmer that needed a 50,000 pound per day extraction facility, and he wanted us to do it for him. So in engineering, you don't go from laptop to 50,000 pounds per day.
No.
And we didn't have the manufacturing capabilities to make something like this anyway. So we located a manufacturer of agriculture and pharmaceutical processes in Minnesota, BPEX International. And they helped us run some pilot studies and actually designed some equipment using off-the-shelf modifications to meet our needs as far as process conditions, and actually were able to do it. So now we have a robust manufacturer behind us that will provide a performance guarantee. These people have been around for 100 years. Their agriculture equipment is robust, rarely goes down, and all our processes are based on these simple unit operations.
Yep.
When you look at that process and that history, it is interesting because it's going from the technology side and looking at other, fuels or diesel fuel or whatever, that you're looking at that process and then saying, okay, what are the commonalities and then how do they fit together? And even the CO2. Cannabis is just another botanical plant. The CO2 instrument does not know what you're putting in it. It's not, just going, oh my goodness, I need to change myself. But at the same time, being able to look at the characteristics of what you wanted it to do, and then it turns out that it moves into a product. So when you talk about scaling from the small to the large, I mean, that's not an easy thing to do. I look at the 3 S's. I look at speed, scale, and selectivity. And so on that side, you're being selective based on what you want, and your speed is it's a fluffy word, as well as scale. So when I'm looking at that, something happens from the time the plant goes in. I know this has got to be true. From the time the plant goes in until you get the 3 types of oil on the back side, there's no magic, and there's no little man or woman in there or a little Oompa Loompa doing anything. So can you explain a little bit what the Oompa Loompas are doing?
Absolutely. It is the Laws of Thermodynamics. And I would say for a couple of years in there, we were like, are we playing within the laws of thermodynamics, within the laws of the physical universe? And yes, we were. So we were able to do
We
this.
were at the wrong end.
We were at the wrong end. We had to switch the
We had to go to the opposite side. But the laws of thermodynamics still govern what you're doing.
Govern what you're doing.
But the process equipment that we're using now is outside the regime of what most manufacturers be building, especially for a continuous process type operation. But we're able to do it. And it was difficult to get there, and most people would have turned away a long time before we did, mainly because of what we were trying to do.
It was hard because I think you're right. Like when you look at the system, when you look at a demo or our benchtop model, it really is as simple as you're going to put in green feed, green plant material on one side, and that plant material can be fresh, it can be frozen, it could be dried. It can be pelletized and then crumbled. It can be really anything. We'll take whatever you give us. I actually mentioned this to someone the other day that my system doesn't care if you have sticks and seeds in it, right?
Yeah.
It might change the color of your oil a bit, but I'm not going to extract sugars, right? I'm not going to extract a whole bunch of problematic components because we're highly selective for what we're looking for here. Sorry, one thing. So you have a few fractions that come off the system, like you're mentioning. There's 3. So the first fraction you're going to get on our system is your monoterpenes, your really nice smelling ones. Those come off at a really low temperature in our system, and we do it fast, under 10 minutes, 5 minutes actually in continuous systems, but 10 minutes in batch. The next fraction you're going to get off is your higher boiling point terpenes, your sesquiterpenes, and then your cannabinoid fraction. In that cannabinoid fraction that we pull off our system, it's over 90% primary cannabinoid content and well over 93% total cannabinoid content, because we've already removed the terpenes. So you don't have your waxes, you don't have chlorophyll or sugars. It's truly a distillate product, straight out.
Back to your triangle with speed, selectivity.
I love your triangle. Sorry, go ahead.
and scalability. I think we're kind of in the middle of that. The speed is about 90 minutes from feed to output. Selectivity, we can get the terpenes, we can get the cannabinoids out. And speed or scalability, well, we can go from a couple 100 pounds a day less up to 50,000 pounds a day. The whole process chemistry is still the same, no matter what you select there within that regime.
Exactly.
So you're sort of playing with the Gibbs free energy, but as let's free Gibbs. So when I go back through the process, so I think of it, when I hear about it, I think it's like a GC gas chromatography analogy. Mm-hmm. And so in the gas chromatography, you use columns that are filled with something called carbowax, and that's because they're long chain hydrocarbons, which would be like a wax. And when you run a GC, you run a temperature gradient to be able to have the material that goes on and have it selectively come off based on its volatility.
Right.
It has to come out as a gas, and that's why it's called gas chromatography.
So you need a sweeping gas with that.
Yes, you need a sweeping gas with that. So when you go back through and you look at this analogy, it seems like that's why you're not getting any of the waxes, because the same way that a GC column keeps its ligands on, this does the same thing. And I think you're frozen.
Without the carbowax, essentially.
Yes. So you're like a supercritical fluid extraction being like supercritical fluid chromatography, where your stationary phase is your sample.
Right.
Yes. So we're able to really hone in on what we want and not extract cats and dogs, as we would call it.
So one of the challenges I hear, and that is the cost of manufacturing. And most people aren't taking in the right calculation for the cost of manufacturing, nor are they using the right numbers. So they believe that when a product is put into a sample, that you have 20% total cannabinoids and you're going to get out but that amount of material. Well, that's not going to happen. And the second part is where is the cost of manufacturing? The cost of manufacturing is all the way back from the time the plant comes in, what you have to do for pre-processing, then you process, and then you post-process, and that's a cycle. That to me is speed. The speed is from the time you come in to the time you go out. And so within that process, people don't typically take into account the dewaxing part of this equation, because you have to put it into ethanol, whatever phase it's in, whether it's 60% with the waxes. And then you have to put it into the freezer, and then magic happens. The fat falls out, just like the turkey fat falls out when you put it into the freezer the night after Thanksgiving. And then what happens is now you take that precipitate, and then you're left with the ethanol plus the cannabinoids, whatever mixture it is, and then you get rid of that. So you're heating and you're cooling and you're heating and you're cooling and you're using a lot of solvent. And so it seems like that most of the time that people don't realize that during the ethanol process that they're taking off the carbons that are C21
right
and above.
Right.
And on your side, are you measuring anything that looks at C21 and below? Are you looking at those long chains also?
I have a GCMS available, and the initial part of the work was looking at not just the cannabinoids, but all the other waxes and things like that associated with it, chlorophyll, things like this. And what we would see is the C16, C18 waxes, or molecular weight hydrocarbons coming off, but anything greater than 20, we didn't see it. And my GC can detect up to C30s. So my focus on trying to reduce that C16 to C18 hydrocarbons as best as possible. And we were able to control that by looking at the temperature that we're operating at.
So that's what most people don't see, is they don't see the dewaxing, because the C16, C18 has the same solubility as the cannabinoids. So they are not based on that separation technology of precipitation. It's not going to happen because there's no differentiation. But you're seeing a differentiation.
Right.
We are. We've been able to reach operating conditions, mainly lower temperatures, to a point now that we're not pulling C16 or C18.
That's impressive. Because that's with a solventless system. So as you're looking at that process, the ability to use it in a laboratory for sample prep, because I'm assuming that not every cannabinoid variety is the same. Are you running the exact same conditions for every type of variety?
No, but we don't have a wide variety of operating SOPs necessarily. So it's really based on the primary cannabinoid. If the primary cannabinoid is CBD, you'll have a series of operating conditions for that primary cannabinoid versus THC, right, which would be different. But those are really the two differentiators in terms of process conditions. Aside from that, if you're operating within them both, you're going to pull your full cannabinoid profile in near equal ratio to what's present in the plant.
So that's an interesting point along the way. So as people go back through and they're wanting to know more about your system and such, where would they find you? I mean, it's hard enough for me to find you guys along the way, but I do have you on a Saturday morning, so I know that the other 5 days you got to be somewhere.
We exist somewhere, yeah. Yeah, so the best place to find us is either our site, which is goloxley.com, or on LinkedIn. If you go to Loxley Systems on LinkedIn, you can find direct access to Steve and me, and we're happy to answer any questions.
So I'll go back to Steve, just because he's sitting there and done a lot of the engineering. So how did you get in? How did you get into this, and how did you figure out a solution? I mean, because you're not a cannabis guy.
No, I'm not. I got a background in chemistry and chemical engineering. Spent some work. When I initially got out of college, I worked for a water treatment company, and then I worked for a company in Golden, Colorado, doing environmental remediation, soils, waters, things like that. And I started to play around a little bit with synthetic fuels. and actually came up with a way to convert methane into highly branched gasoline fractions. So a high octane gasoline using light and water as a catalyst. And spent a couple of years on that, got a patent on that, and became more and more interested in synthetic fuels, and hooked up with a bioremediate or bio fuel company that takes trash, municipal trash, and wood pellets and wood chips and things like that, and converts it into electricity, like making something called producer gas, which is carbon monoxide and hydrogen, and a little bit of nitrogen in it, and they burn that in an engine to make electricity. Well, I figured out a way to take that carbon monoxide and hydrogen and make diesel fuel, aviation fuel, and waxes out of that using something called Fischer-Tropsch, which was developed in World War II, and it's been used in the petroleum industry for years. Sasol does it. The problem is that you had to use a really expensive catalyst, a cobalt catalyst, to do something like that. And I was able to find a cheap resource, actually sand from New Zealand, that uses a catalyst to convert these gases into diesel fuel, aviation fuel, and waxes. So I had to play around with both gaseous chemistry, catalytic chemistry, distillations, vacuum distillations of your product. So I got a whole range of chemical engineering operations that I got to deal with. And started looking at the cannabis industry, and I said, well, maybe I can apply some of what I know in the background into this. So I looked at vacuums, looking at pressures, flow rates, how to optimize everything so you can get the product out that you want.
So having the, was it New Zealand beach?
Yeah.
Sounds like a son of a beach type of project.
The best part was him flying there to get the sand.
Yeah.
Wow. So it does go back through and then going through scientific principles, and then, I mean, it's possible you would have never come up with a solution, but it looks like
Right.
you have come up with one.
For a while, we thought we were banging our heads against the wall for a couple of years there.
Yeah.
We just couldn't get the breakthrough that we needed. The product really wasn't as nice as it needed to be. It had to be comparable with what you got off a short path distillation. And that's really what we wanted. We could never get it till a couple of years ago.
Yep.
So the interesting part to me from talking earlier in the week, and that is having built the very large systems and building them larger and larger, because that was the biggest process. And then one day the lightning struck you, or economy struck you, or something struck you. And then last time I saw you guys was at MJ Biz with that great virtual reality. I am the molecule inside the instrument, and then
Oh yeah.
and then what happened?
Yeah, we went to MJ BizCon, really kind of debuted there at scale for the first time, and realized that the marijuana industry was not needing anything close to the scale that we were offering. We came in with something around 750 to 1,000 pounds a day, and that was off the charts, larger than what anybody needed. And when we looked into the economics of the industry, it made sense. Even though you have these huge multi-state operators, more consolidation in the industry, the regulations prevent you from doing what most industries in manufacturing do, which is consolidate your operations, right, to lower overhead. So rather than having large single processing houses like you would have in most other industries, they're dividing it up between 12 states. So they don't need a facility that does 2,500 pounds every day. They need 10 of them that do 200. So we went back to our manufacturing partner. We launched some trials, and now we have a whole new series called the LJ series. We can go as low as 10 pounds per batch and up to about 50 pounds a batch. And they're coming in lower than most of the equipment costs on other solvent-based tech. But I think the most important thing about this model, this LJ series, is that we eliminated the pre and the post process. So you don't need anything other than a Loxley. No pre, no post.
So it does bring me right now, because I was thinking, what does LJ mean? Then I thought Loxley, and so LJ means Little John.
Oh yeah, it does. It's the Little Johns.
Wow, that's pretty funny. So that brings me to the part of, how did you come up with Loxley? There's no Loxley in your family, is there? And it has nothing to do with bagels and cream cheese and salmon. So where does Loxley come from? Now that already broken part of it with the Little John. Where does Loxley come from?
Well, our last name is Sherwood, so we had to do something Sherwood foresty. So we went to the Robin Hood story.
Yeah.
And Robin is Robin of Loxley. Before he was sort of the hooligan, the hooded figure. Yeah. Later, he was Robin of Loxley. So we're Loxley Systems, and our 5 series are the Little Johns, Robins, Marions, Tucks, the Prince, and the King series. It's like Yep. So we got the full cast of characters here.
Oh, with the King series, I'm a little anxious about that one. I mean, do you steal from the King and give to the
steal from ourselves?
You steal from yourselves and such. So I'm making sure that we have some time. I know that you only have a certain amount of time and such. So even within that process and being able to look at a demo, some of the things that were interesting to me was that you set up a smaller system so that you can actually do lab scale experiments. And of course, I'm a geeky guy, so I realize I don't have 25,000 pounds of cannabis to throw in an instrument and say, gee, I wonder what happens. So tell me a little bit about your bench top system.
Yeah, it's actually a pretty new contraption. Just in the last couple of months, we realized that even carting around the Little John series, those things are several hundred pounds. So it wasn't really feasible for us to move something that fit in like a suitcase or a briefcase to multiple different like marijuana manufacturers and bring it on site so we could actually process marijuana in front of them. Yeah. So we set up an entirely glass rig that meets all of our conditions. So you can see every single thing happening that would happen inside the system. You can watch the oil come off, watch it be collected, and it allows a demo participant to really see what's happening rather than saying like, here's our very large piece of steel and you'll get some oil out on the other end. Yeah. That
sounds good. So I'll wrap it up for you all and stuff. And thank you so much for taking your Saturday morning and participating. So I will make sure that people get the information, but maybe tell us one more time how to get a hold of y'all. That would be good. So
definitely,
tell me how to do that.
You can go online to www.goloxley, GOLOXLEY.com, or give us a phone call at 720-509-9707. That's the easiest way to get a hold of us. The form on our site goes directly to my email now, so I will respond to you within the day. Any questions you have?
Great. Thank you so much for your time.
Thanks, care. John.
Have a great
Thank
weekend.
You so much, John.
Go Broncos.
'Tis the season?
Not yet.
It's the season. Have a new time with a new quarterback. Enjoy yourself. Doesn't he have to? Yeah. He has to throw it to somebody.
Somehow.
All right. Cheers. Take care. Bye.
Thanks, John.
Soon,
Take
John.
care.
Thank you.